Hello friends, welcome to my channel. Today I am going to show you how you can use a new free software for fitting your EIS data into some really good equivalent circuit. Recently I have got this software and I heard about this software from one of my research collaborators. Here you can see the software EIS spectrum analyzer, and I have downloaded this software from this website, that is ABC Chemistry, and it is free. You also can download it, and most importantly, you don't need to have any access to the internet while you are using the program, the application, and you don't also not require any instrument, that potentiostat or electrochemical workstation connected with your PC or laptop while you are fitting using this application. So you can see they are the authors, and here's one reference, and you can download the program from this website, and I shall put the link in the description section. So this is a pretty nice software, and before using that, let's talk about something. Here you can see the library. There are plenty of equivalent circuits given. So if I click this bar 2 to 4, you can see under this section you will get some equivalent circuits having 2 elements. In 3 you have 3 elements, and for 6 you have 6 element circuits, and likewise. So you can see some given circuits in the library. You can access the circuits clicking here, or you can bring it from here also. It's the shortcut. Apart from that, you can draw your own equivalent circuit if you want. So you have to click here, and you can see the circuit elements are there, lots of circuit elements. You can define your circuit element as well. So C means capacitor, resistor is there, work impedance, constant phase element, inductor, work short, work open, and jerisher. Lots of things are there. So you can do like this. Suppose I want to have one resistor here, so I have clicked on R and I have got the resistor, that is R1. Now I want to add one capacitor in series, so let's click here. You get it. Now say I want to add one capacitor parallel to the resistor R1, so here. So what I did, I went to I chose this parallel and I chose capacitor. Now suppose you want to edit this element, you don't want capacitor to be here, instead you want one constant phase element. So in that case, if you want to change the element, you can go to this edit element, click here, and suppose I want to have CP instead, so I click here, and you see that I have got CP, the one constant phase element, and it was earlier C2 and it has been changed to C1 now. So if you want to delete the circuit, you have to click this clear model and it will go. Now let's bring one data file for fitting. Now the data file, what you can use here has some format, definite format. So for that I have opened one EIS data file. I obtained the data from CHI 660D instrument, electrochemical workstation. Here column A is representing the frequency, column B is representing Z prime, which is the real part of the impedance, and this column C represents G double prime, which is the imaginary part of the impedance in negative. And I need column A, B and C for using the EIS analyzer, which I have shown you. And the format for the data is, first of all, you have to have this real part of the impedance as the first column. So I have selected this, I have made this column here. This is real part of the impedance. Then the negative, I have got this G prime column here, and I have multiplied the G prime values with -1, so that I get minus imaginary part of the impedance. You can see here, and here I have taken the phase values corresponding frequency values. So you have to have the real part of the impedance as the first column, then the minus imaginary part of the impedance as the second column, and frequencies as the frequency values in the third column. And you also have to note the number of data points you have in the each column. Here the data count is 73, so you have to note that. So let me show you how a typical data file looks like. So here I have already made one data file. The spelling is wrong here, however. So you can see 73 is the number of data points in each column, and this is column, this first column is representing the real part of the impedance, followed by the minus imaginary part of the impedance and the frequency. So you have to have this format for analyzing your data using the EIS analyzer, which is a free software. So let's go back to the software and open the data file. So let's open it, and you can see nice Nyquist plot here, where the y-axis is representing the minus imaginary part of the impedance, and the x-axis is representing the real part of the impedance. This is the Nyquist plot. If you want to have the nice body plot, then go to the graph section and choose theta versus frequency, and you will automatically get this nice body plot. You can also have the modulus of z versus frequency plot, that is mod impedance versus frequency, like this. But I don't need it right now. So let's go back to the Nyquist plot, and you can see there are several algorithms available here. I shall choose Newton here, and I shall check in this amplitude. Now you can bring one circuit, equivalent circuit here, by selecting this circle and send to EC panel. So the circuit has come here, it has appeared, and you go to this green F and ask the software to fit. So you can see that it has completed the fitting, and here's the values R1, R2, R3. R1 is the ESR value, that is equivalent series resistance. R2 can be said as the bulk resistance, and R3 can be said as the surface charge transfer resistance. And these are the constant phase elements, which are what I know that imperfect capacitors. So you can see the values, you can note the values if you are satisfied with this plot. Here are the error values and resultant the values. Let's go to the body plot. Here's the body plot, you can see it, and you can also go to the simulation and click this blue S to, and you can see the application, the software has simulated, got this result for this circuit. It is the circuit, and you can check the body plot as well. Here it is looking like this, and the application has simulated this thing for this circuit. Now say I don't want this, and instead I want to draw one circuit myself. So let's clear it, and you can go to the fitting like this. So let's draw one circuit here. So let's draw one resistor followed by one CPE, and let's connect one capacitor in series. Now let's add one resistance, one resistor in parallel with this CPE. So here, now let's connect another resistance with this C1 in parallel. Now suppose I don't want this resistance here, instead I want to replace this with one impedance, that is GW. So edit element and change it to W. Here it is. Now let's try to fit it. So fit it. Yeah, it has been done. So you can see the values, and let's try to fit it again. Now there are some features you can use. Before that, let's check the body plot. So here's the body plot, and let's go back to the impedance Nyquist plot. And what you can do, you can delete some data points if you want. So clicking here, so delete data point, let's delete that point, and now you can fit again. So, and let's the value is not quite good. Let's try to fix it. It is not working by this. So let's delete this model, and you can bring that data again, and let's fit the circuit again. Let's try to fit. Let's delete this, and there is one option by which you can do that fitting for one particular section, that is fragmentary analysis. I am not going to do that. Instead, let's try to fit it again, and this time I have got this result. And let's go to the body plot. So it is matching quite nicely, I guess, and you can see the error for R1 is 17%, and for R2 it is 3.5%, and so on. You can check that. So I think I am satisfied with this result, and you can note this circuit, equivalent circuit, and the values on your notebook if you want. Otherwise there are some option like creating report, and some going here, create HTML report. For that you should move this tab here, otherwise the circuit may be blocked. So create report and HTML file, save. So let's open it. You can see it, the body plot, and as I mentioned that sometimes you cannot see the circuit, however you can get the circuit parameters and their estimated values. Okay, and there's another folder here. Also the equivalent circuit is not being shown, so better I will recommend to manually note the equivalent circuit on your notebook. That would be a better option, and you can simulate this result. Okay, let's see how the circuit produces that Nyquist plot. So this is that Nyquist plot for this circuit, and it is overlapping quite nicely with that experimental data. And let's see the body plot as well. So you can see there are some shift in the peak positions, however otherwise it is matching nicely. So I am quite satisfied with the fitting and the result, and I will recommend you to manually note the circuit. It is not a big issue. So I think you have understood how to utilize this EIS spectrum analyzer. I have downloaded this free software from this website, and they are the authors of this EIS spectrum analyzer 1.0, and it is the reference of this program. You can see this, and it is quite easy. If you work with it few days, then you will be happy to use this program, and you don't need to connect your PC with the electrochemical workstation, and you don't also need to have internet connection while you are performing the fitting. You can customize the equivalent circuit according to your requirement. However, there are some problem. If you use, you will understand that. So still I think it is pretty good software, and you can get some really cool data, cool fitting using this. There are plenty of other options you can explore, and lots of algorithms and functions are there. U element, I am not expert in defining user defined element, so let's leave it for the pros. Okay, I am clearing the graph, and hope you have understood the basic things about this software. I have shown you how to make the typical data file which can be used by this software. Otherwise, if you bring some raw EIS data and try to open it using this software, it will not open. It has a specific format, you have to follow that. And if you are using data from different instrument, suppose biologic instrument, then please don't forget to have that frequency values. Otherwise I think it will not be opened using the program. So in CH instrument data you get all the things, frequency, Z prime, Z double prime, so it's quite nice. I also have used that biologic instrument and published paper also. So they are for Nyquist plot I only noted the Z prime and Z double prime values, because if you are doing manually the Nyquist plot you don't require that frequency values. However, if you want to use this free software, please get those frequency values as well, it will be required. So if you have liked the video, please like, and if you haven't liked, please dislike the video and make comment why you haven't liked that. And if you think this is beneficial for you and your community, research community, so then please share this video with your friends, colleagues. They can also be benefited, because lots of people find such software, such application, it is very nice, I think. So I was also finding such software. One of my research collaborators suggested this software, and so with this, please consider subscribing my channel and stay well. Thanks a lot.